Hey guys, we haven't done a new video in a while, so this will be fun to see if anything's different. You will have to let me know if the video quality is too poor. We got a new camera and I'd like to test it out. All right, so 5-3, I redid all the notes, and the main idea is you guys are going to have to factor and use a quadratic formula a lot. So right here, special note, when you can't factor, you may need to use the quadratic formula. And that's the negative b plus or minus. You're pretty well versed in that by now. We'll practice as we go along. All these are the different types of factoring you can do. I mean, if you want to, you can take the time to review each one of these, but I am going to go through each one individually. I have the main set of steps on the back of your paper. I solved the notes already before I did this, and I did notice 4 major steps in each and every one. I'm going to do my best from this time out to get you guys through as many problems as I can in 15 minutes because that's when I get to go home. And then I'll do the other ones in another video. All right, so step number 1, any type of problem you have, you do need to set it equal to 0. So you're going to take your 6x to the third to the other side by subtracting it. So step 1, you're going to have 3x to the fourth minus 6x to the third plus 12x squared, and that's going to equal 0. After you set it equal to 0, you're going to need to look for a GCF. This is type 1. It's a GCF, and you're going to see that it's not going to factor. Step 2, you should notice there is a GCF. There is a GCF as 3x squared. Something else I do want to point out to you on step 1 is from the back of the page, if you look at your steps, I said I'm going to put each one of these on the calculator after it's solved for 0. So I'll have 3x to the fourth minus 6x to the third plus 12x squared, and that's it. When I hit graph, what I want you to notice is that it is going to cross the x-axis at 0, but nowhere else. This is going to be a good picture for us. All right. Does everybody see how it has an exponent of 4? There will be 4 solutions. Okay? And that's because of the exponent of 4. I'll teach you where those 4 solutions are. So when you divide by 3x squared as our GCF, you're going to end up with 1x squared minus 2x. Divide by 3x squared, we get plus 4 in the back. This is still all equal to 0. This outside item, this is step 3 if you look at the back of the notes. The back of the notes, step 3 says decide if you can factor it or if you need to use the quadratic formula. So we're going to look at this item right here. There is nothing that multiplies. There's nothing that multiplies to positive 4 and adds to negative 2. So this does not factor. If you're not sure, you can just do the quadratic formula anyway. But because it does not factor, we will need to use the quadratic formula. Step 4 is to solve. So the first item that we factored is 3x squared. That needs to get set equal to 0. Let's divide each side by 3. So we get x squared equals 0. Take the square root of 0. We get technically plus and minus 0, which I know is just 0. But at least we can see 2 of our solutions are 0. So 0 happens twice. The other solutions come from this parenthesis, and we're going to need to use the quadratic formula. So we do negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And I already have the notes done, so you can plug that in your calculator. You should know how to do that. You get 2 plus or minus the square root of, that ends up being a negative 12 inside of there. And then you need to remember that 12 is 4 times 3 is a perfect square. I'm going to move up to this side of the paper. So you get 2 plus or minus. You take the square root of 4. Because this was a negative, please remember that we're going to need to use an I. So the square root of 4 is 2, and then an I. Square root of, we had a 3 down here, so square root of 3 all over 2. And then divide all the outside numbers by 2, so you get 1 plus or minus 1i square roots of 3. If you remember on the graph, we saw it crossing at 0, but I told you it had 4 solutions. Well, the 4 solutions are the fact that it happens at positive and negative 0. I know that's not really just one solution of 0, but that way you can see that it's 2 solutions there. And then there's 2 imaginary solutions because it doesn't actually cross because this is not an imaginary axis. So our real solutions are 0 and 0, and our two imaginary solutions are 1 plus I squared to 3 and 1 minus I squared to 3. And that takes care of the 4 solutions that I told you there would be at the beginning. Okay, let's take a look at type 2, GCF, and it does factor. So step 1, I wrote on the back side of your notes, is to set this equal to 0. So it's 2x cubed minus 5x squared minus 3x equals 0. And the next thing we're going to do, if you look at step 2 in the back of your notes, I asked you to find a GCF if possible. There is a GCF of just an x. So when we take that x out, we're going to get 2x squared minus 5x minus 3. And that's all going to equal 0. I also said in step 1 we should put it in your calculator. So we find a good spot for that. Clear it out. 2x to the third power. Say hi, Miss Stonebreaker.
Hi.
Minus 5x squared. And then minus 3x. So when we graph it, let's take a look. It's going to cross, oh, it looks like it crosses in possibly 3 places. It looks like it crosses here, here, and here. And I'm going to teach you all of those places in the video here. I want you to notice that this one should have 3 solutions because it has an exponent of 3. That exponent of 3 means 3 solutions. And I think we saw all of those on the graph. Step 3, I do want you to recognize that we're going to try to factor this one. If you don't factor it, you could use the quadratic formula because it is a squared. So you go ahead and pick. I am going to factor it though. So if you do the box method, you would do 2 times negative 3 is negative 6. It needs to add to negative 5. Those numbers would be negative 6 and positive 1. And then you can go to the box. The video is lagging. Give me a moment to catch up. There we go. So inside the box, you'll have 2x squared here, a negative 3 here. You guys are used to this, negative 6 and 1x there and there. You're going to drop down a GCF of 2x, and then a plus 1, and then a GCF of x and a minus 3. That's factored, and it does factor, unlike the last problem. Step 4 is you're going to solve. So I have that x, I'm going to draw an arrow so you know what it came from. I have that x, and then I have my 2x plus 1 from my box, and my x minus 3 from my box. And all those are going to equal 0 individually. So the first one's nice and easy. X is 0. That's one answer. And if you look at the graph, it does cross at 0. The second answer is 2x plus 1 equals 0. Subtract 1 to get negative 1. Divide by 2 to get negative 1/2. And then the last one is x minus 3 equals 0, and you would get x equals 3. So I have all 3. If you remember on step 1, we said there were 3 solutions. 1, 2, 3. None of them are imaginary. They're all real. So my answers are 0, negative 1/2, and 3. And you can see those all on your XY chart. There, or XY graph. There's negative 1/2, there's 0, and there's 3. I'm going to keep going till I reach the 15-minute mark. So let's take a look now at type 3, difference of perfect squares. These ones are kind of old school. So step 1, set it equal to 0. 4x to the 4th minus 25 equals 0. And you should notice that these are perfect squares. So step 2, you should note there is no GCF. In step 3, we're going to try to factor it. And it does factor, again, because it's the difference of perfect squares. You cannot do the quadratic formula. I should have mentioned on the last one you could do the quadratic formula because it was squared. So if you ever see a squared, you can do that. Let's put this in our calculator. So we have 4x to the 4th minus 25. And when we hit graph, oh good, I can see that we at least have 2 places that it's going to cross the x-axis. Now, if you've caught on in the past couple of problems, we are going to have 4 solutions because of the exponent of 4. I found 2 of them on my graph, but we're going to find them all by factoring. So as we factor them, we're going to take their square roots. Okay, so we do the square roots of them. So the square root of 4x to the 4th is 2x squared and 2x squared. And the square root of 25 is 5 and 5. One's a plus and one's a minus. Step 4, you're going to solve each of those for 0. So you'll do 2x squared plus 5 equals 0 and 2x squared minus 5 equals 0. And on both of them, you're going to solve. So we get 2x squared equals negative 5. X squared equals negative 5 over 2. And when you take the square root, we get a plus and a minus I, because it's negative, square root of 5 over 2. Now, if any of you are wondering if this is really an acceptable answer, no, it's not. But we're going to let it go. We should rationalize it, but as long as you get here, I think you understand enough that I'm happy. So on this one, we're going to add 5. So 2x squared equals a positive 5. Divide by 2, so you get 5 over 2. Take the square root. Remember, when you draw a square root, you need to use a plus and a minus. That's square root of 5 halves. You should, oh, sorry. So we did, I'm not sure, the video keeps lagging. You divide by 2, so you get 5 over 2. Take the square root and use plus or minus. You should rationalize this by multiplying top and bottom by square root of 2, but for our purpose for right now, I want you to see that there's 2 imaginary answers and there's 2 real answers. So the 2 real answers are plus and minus square root of 5 over 2, and the 2 imaginary answers are plus and minus I square root of 5 over 2. And that does fit our graph. Whatever square root of 5 over 2 is, let's check that out real fast. So 1.58, if we look at our graph and we zoomed in, it really does look like it's crossing at 1.58 and negative 1.58, which is why that's an answer. All right, let's